Welcome students to Earth Educational Channel. Good morning, good afternoon and good evening to everyone who is joining at any time. Okay, so we have covered 4 sections of the chapter number system. The last section we are going to cover it today, and this is a small section. We will go through it quickly, and this is a section that we have already learnt in previous chapters. Okay, in previous classes also you have learnt about it. So this is about the laws of exponents. This chapter is about laws of exponents of real numbers. Okay, laws of exponents of real numbers. This is a chapter, so we are going to discuss about it. What are the laws of real numbers, exponents of real numbers? Before that, you have already read about it, about the laws of exponents using natural numbers. Okay, let me write those laws first. Okay, what are those laws? Suppose we take 4 natural numbers a, b, m and n. Okay, let a, b, m and n are natural numbers. Okay, a, b, m and n are natural numbers. The laws, what does those laws state? Okay, in those laws, see, let me write one law first. Okay, the first law is a to the power m into a to the power n can be written as a to the power m plus n. That means if you multiply a number that is a to the power n into a number that is a to the power n, so we can write it is same as a to the power m plus n. The power gets added. Okay, so what we call these actually? See, a and b are called bases. A and b are bases. These things are called bases. Okay, the powers m and n are called exponents. Understood? The powers in am, a is the base, sorry, m is the exponent. Understood? A is the base, m is the exponent in a ki power m. So this is the first law. Like if the base is same, and if the base, if you are multiplying two numbers whose base is same, so the power gets added. Understood? Second one is, we are writing a ki power m ki power n. If the number is a ki power m to the power n, the power gets multiplied, m into n. The power gets multiplied, a ki power m into n. Okay, then if it is division, a ki power m by a ki power n, if a number is such that a ki power m by a ki power n, the power gets, the exponent actually, power I am telling, power is exponents. The exponents are subtracted. Okay, the exponents are what? Subtracted. If it is multiplied, it is added. If it is divided, it is subtracted. Okay, sorry. And a ki power, if the bases are different but exponents are same, here bases are different and exponents are same and they are multiplied, we can multiply the base and then give the power exponent. Okay, overall exponent will be m. We can multiply the bases and we can the overall exponent, and any base to the power 0 is equals to 1. Okay, and the last point is, if a base has an exponent that is negative, if a base has an exponent that is negative, so you can write it as 1 by the base to the power exponent. Okay, a to the power minus n can be written as 1 by a ki power n. If you want to remove the minus, you have to write 1 by a ki power n, or it can be written as, see, this is 1 by a ki power whole n, because 1 ki power n is actually 1 only. That is why it is 1 by a ki power n. Understood? Otherwise, this is the initial form, 1 by a ki power minus 1 is equals to 1 by a. Then it is a ki power minus 1 into n. So it is 1 by a ki power n. From here we are getting a1 by a ki power n, because 1 ki power n is 1 only. Understood? So these are the 6 laws. See, a ki power m means if the bases are same but exponents are different and multiplying those numbers, we add the powers. If we divide, if the bases are same but if we divide the numbers whose exponents are different, we subtract the exponents. If we means the exponents are in power twice, so we multiply those exponents. If the exponent is same but bases are different, so we multiply the bases. And if to any base the exponent is 0, the answer is 1, and if it is negative, we can write it as 1 by an. Okay, some examples we will check. See, 17 to the power 2 into 17 to the power 5, it is written. From the first law we can do a ki power m into a ki power n equals to a ki power m plus n. Instead of a it is written 17, instead of m it is 2, instead of n it is 5. So this is 17 ki power exponent 2 plus 5, that is 17 to the power 7. This is first question. Second question is 5 square to the power 7. It is of the form C, a ki power m ki power n. We know it is a into a to the power m into n. So a is what? 5 here, m is 2 here, n is 7 here. So this is 5 to the power 2 into 7, that is 5 to the power 14 is the answer. Understood? Third question is 23 to the power 10 by 23 to the power 7. Okay, so we know a to the power m by a to the power n, if you write, it is a to the power m minus n. Okay, if the base is same but the exponent is different and we are dividing those numbers, so we will subtract the exponents. So see, instead of m a we are writing 23, instead of n it is 10, instead of n it is 7. So 23 to the power 10 minus 7 is 23 to the power 3 is the answer. Okay, then 7 to the power 3 into 9 to the power 3 equals to, we have read if the power exponent is same but the bases are different, we will multiply the bases to the power m. Okay, so this is bases are different but exponent is same, so we will multiply the bases. 7 to the power 7 into 9 to the power 3, this is 63 to the power 3. Understood? Now you see, here all are positive, here all are positive, all m and n are positive. Okay, when m and n can be negative, the same laws apply. Okay, here I had written that all are natural numbers. Natural numbers means they are positive only, but if they are negative also, the same laws will apply. If the exponents are negative also, the same laws will apply. Example I am showing you. First one, 17 to the power 2 into 17 to the power minus 5. Okay, so this will be that same formula used, a plus a to the power m into a to the power n equals to a plus m. So this is 17, instead of n m we are writing 2, plus instead of n this is minus 5. So what you are getting? 17 2 minus 5, that is 17 to the power minus 3. So you can write it as 17 to the power 3 also. Understood? From the last law, a to the power minus n equals to 1 by a to the power n. You can write it. Similarly, okay, 5 square, I will not write these again, the formulas, you have to remember them. Okay, 5 to the power 2 minus 7. We know we have to, in these cases, we have to multiply the exponents. This is 2 into minus 7. Okay, so 2 into minus 7 is minus 14. So 5 minus 14. 5 to the exponent to the power minus 14 is the answer. Or you can write it as 1 by 5 to the power 14. Okay. Third example is 23 to the power minus 10 by 23 to the power 7. We know we have to subtract it. So 23 to the power minus 10 as it is, then again minus, then 7 is there. Instead of n, 7 is there. This is minus 10 minus 7 is minus 17. So this is 23 power minus 17 equals to 1 by 23 to the power 17 we can write. Okay, last example is 7 to the power minus 3. 7 to the power minus 3 into 9 to the power minus 3. Understood? We know if exponents are same but bases are different, we will multiply the bases. This is 7 into 9 to the power minus 3. Understood? So this is 63 to the power minus 3. 63 to the power minus 3. So we can write 63 to the power 3 is the answer. Understood? So these are the applications of the laws that I have written. Okay. Now what we can do is we can extend the above laws. We can extend the above laws for bases. For base, let me write it properly. For base being positive, base being positive real number, and the exponent rational numbers. See, I have said that A, B, M and N were positive numbers. Then I shifted to M and N are negative numbers. Then also the rules apply. Now what I am doing is I am making base. Base is positive real number. Okay, positive real number. Exponent is but only rational number. Understood? Exponent is only, see, irrational number also it will come, but that is outside the scope. Okay, so exponent is irrational number. So the definition, see, let a greater than 0 be a real number and n be a positive integer. See, here rational number we need. We are going first with integers. Then we will go to here. See, everything was integers. But here we are going to write about real number with the exponents as integers. Will be a positive integer. Then a nth root. This thing you will read as, see, this thing. If you write something like this, this is nth root of a. You will read it as nth root of a. Understood? This is square root. If nothing is written, we consider it as 2. Okay, this is square root. If 3 is written, this is cube root. And then you have to say 4th root, 5th root. So this is nth root. Okay, then nth root of a equals to b if b to the power n equals to a and b is greater than 0. Okay, if you are getting b, understood? If you are getting b to the power n, b to the power n equals to a, then nth root of a equals to b. Okay, so in exponent form, see, when the exponent changes the sides, okay, it becomes 1 by n. If n goes to this side, no, it will become 1 by n. You are getting it? It becomes the reciprocal actually. The power becomes the reciprocal. Okay, if power goes to the other side, it becomes the reciprocal. See, in exponent form, our nth root of a equals to, what are we going to write? A to the power 1 by n. Understood? A to the power 1 by n. See, b to the power n equals to a. So b is what? A to the power n. B is a to the power, if power changes side, no, it becomes its reciprocal, that is 1 by n. And this thing is only equals to nth root of a also. So nth root of a equals to a to the power n in exponential form. Okay. Example, suppose we are writing cube root of 2. So in exponential form it is 2 to the power 1 by 3. You got this? See, we'll take an example now how to solve. Solve 4 to the power 3 by 2. 4 to the power 3 by 2. Okay. There are two ways to solve it. There are two ways to solve this. Okay. We can write 4 to the power 3 by 2 as 4 to the power, not like this, wait, 4 to the power 3 into 1 by 2 you can write 3 into 1 by 2. This is the same thing, 3 by 2 can write 3 into 1 by 2. And from the first law, see, from this law, second law, a to the power m to the power n equals to a to the power m into n. So from this we can you can do two times. First time I am taking 3 inside. So this becomes 4 to the power 3 to the power 1 by 2. So 4 to the power 3 is what? 64 to the power 1 by 2. And we know by exponent form 1 by 2 means root over of 64. Root over 64 is 8. So 8 is the answer. Otherwise, what you can do is you take this time 1 by 2 inside first. 4 to the power 1 by 2 to the power 3. So 4 to the power 1 by 2 is means root over of 4 to the power 3. Root over of 4 you know the value is 2. 2 to the power 3 equals to 8. We're getting the same answer. Okay. So this is the way of solving finding the value of 4 to the power 3 by 2. So now what we can do, we can write and extend it. Let a greater than 0 be a real number. Okay. Here also we need a positive real number. Here we are taking a positive integer. N be a positive integer we are writing. But now what we saw? From this, what we saw? This is the nth root. From nth root it was 1 by n. So we solved it. Okay, we solved this 4 to the power 3 by 2 also. So from there what we saw? We are writing let m and n be integers such that m and n have no common factors. M and n have no common factors other than 1 and n is greater than 0. N is greater than 0. Then see, a is greater than 0, m and n be integers such that m and n have no common factors and n is greater than 0. You have to have m and n as no common factors. Okay. So if you write a to the power m by n, okay, so that is you can write in two forms. See, these are the two forms actually. A to the power m by n can be written as, see, I am writing the formula first, or wait, I will show you how it is happening. Okay. This can be written as a to the power m into 1 by n. Okay, m by n can be written as a to the power m into 1 by n. I already did this thing. I am again telling you, a to the power m into 1 by n. So if you write a to the power m first, okay, this can be written as a to the power m to the power 1 by n. And you know 1 by n means, from here I am saying 1 by n means nth root of that number. So this becomes nth root of a to the power m. Or you can write same thing again equals to, if you take 1 by n inside first, 1 by n a to the power 1 by n to the power m. Now 1 by n means a to the power wait this means nth root of a, then its whole to the power m. A to the power 1 by n means nth root of a whole to the power m. So these both are same. So the formula is actually a to the power m by n can be written as either nth root of a to the power m or nth root of a whole to the power m. Either nth root of a to the power m or nth root of a to the power m. Okay, so this is the formula. Understood? So we are going to write now the laws of exponents of real numbers. Okay, let me take on another page. Okay, now those were the laws of natural numbers. We are writing about natural numbers. Now we will extend those laws to the exponents of real number. Now the laws of exponents of real numbers. Exponents of real numbers. Okay, so let a to the power 0. See, these all were the exponents were integers. Here the exponent was only a positive integer. Then here integers, only integers. Okay, now we are extending it to rational numbers. A greater than 0 be a real number. A greater than 0 be a real number. And P and Q be rational numbers. Okay, see, the first part were here at the start were the exponents were natural numbers. From natural numbers we went to positive integers only. Okay, from positive integers we went to integers, that negative can be there. From integers we are going to the exponent being rational numbers. P and Q be rational numbers. Okay, so the first law that is satisfied, the laws will remain the same. A to the power P into A to the power Q. If the base is same but the exponents are different, so the exponents will get added. A to the power P plus Q. Okay, second law, same thing, A to the power P to the power Q. So the exponent gets multiplied. If 2 times power is there, so the exponent gets multiplied. A to the power P into Q. Third one is A to the power P by A to the power Q. A to the power Q. If the base is same but the exponents are different and they are divided, so the exponents get subtracted. And the fourth one is, okay, here the exponent is remaining the same but the base is different, so we'll multiply the base itself. Or P equals to AB to the power P. Understood? So these are the laws, 4 laws of exponents of real numbers that I have written. If base is same but exponents are different and the numbers are multiplied, so the exponents will get added. If it is divided, it will get subtracted. The exponents will get subtracted. If the exponents are to the power twice, so they are multiplied. And if the exponent is same but the bases are different, the bases are multiplied. Okay, now we'll go for examples. Example 20, what it is given, it is told to simplify. It is told to simplify. The first one is 2 to the power 2 by 3 into 2 to the power 1 by 3. Okay, make a to the power m into a to the power n equals to a to the power m plus n. Instead of a it is written 2, m instead of m it is written 2 by 3, instead of n it is written 1 by 3. So you do 2 to the power 2 by 3 m plus n, a to the power m plus n. This is 2, this is 3 by 3, it gets cancelled. This is 2 to the power 1 equals to, answer is 2. Understood? Second question, it is written as 3 to the power 1 by 5 to the power 4. See, we have written a to the power m to the power n equals to a to the power m into n. Instead of a it is given 3, m. Instead of m it is given 1 by 5. Instead of n it is written 4. So we'll substitute that. Instead of a we are going to write 3 to the power m. M instead of n we are going to write 1 by 5 into 4. This can be written as 3 to the power 4 by 5 is the answer. Understood? Third simplification that you have, it has been said 7 to the power 1 by 5 divided by 7 to the power 1 by 3. Okay. So the third law, a to the power m by a to the power n equals to a to the power m minus n. Instead of a it is written 7, m it is written 1 by 5, n it is written 1 by 3. So 7 to the power 1 by 5 minus 1 by 3. Okay, you solve this. You are getting 7 to the power 15, 3 minus 5. So this is 7 to the power minus 2 by 15. Understood? Or you can write it as, this is 7 to the power minus 1, you can take aside. This can become 1 by 7 to the power 2 by 15 also you can write. Okay. Then fourth simplification, that is 13 to the power 1 by 5 into 17 to the power 1 by 5. Okay. So here the bases are different. So but the power is same. Exponent is same. So we'll multiply the bases. Here a to the power n into b to the power m equals to ab to the power m. Instead of a 13, b is 17 to the power n. N is 1 by 5. Okay, 1 by 5. So 13 into 17 is 221 to the power 1 by 5 is the answer. Understood? Now we'll go for the fifth exercise. Exercise 1.5. First question is find what? 64 to the power 1 by 2. See, 64 we know, 8 square equals to 64 we know. So this can be written as 8 square to the power 1 by 2. Then we know this form we have to multiply the exponents. So 2 into 1 by 2. 2 gets cancelled. This gives 8 to the power 1. This gives 8. This is one thing. Second is 32 to the power 1 by 5. 32 to the power 1 by 5. We know 2 to the power 5 is equals to 32. So 32 we can write it as 2 to the power 5. Now it is looking as 25. 2 to the power 5 to the power 1 by 5. We know we have to multiply the exponents in this form. So 5 into 1 by 5. 5 gets cancelled. Only remains 2 to the power 1 equals to 2 is the answer. The third simplification given is 125 to the power 1 by 3. Okay, we know 5 to the power 3 equals to 125. So instead of 125 we can write 5 to the power 3 to the power 1 by 3. In this form we know the powers exponents get multiplied. So 3 into 1 by 3. 3 cancel. 5 to the power 1 equals to 5. Understood? Then second it is given. Second question is find. Again, this time find 9 की power 3 by 2. Okay, we know 9 equals to 3 square. So instead of 9 we are going to write 3 square to the power 3 by 2. We know in this form the exponents get multiplied. So 2 into 3 by 2. 2 gets cancelled. So it remains as 3 to the power 3 is equals to 27 is the answer. Okay. Second find, it is given 32 to the power 2 to the power 5. 32 to the power 2 to the power 5. Okay. We know 2 to the power 5 equals to 32 we know. So instead of 32 we are going to write 2 to the power 5 and 2 to the power 5 to the power 2 by 5. In this form we know the law that the exponents will get multiplied. So 5 into 2 by 5. 5 got cancelled. So remains is 2 to the power 2. That is 4. Understood? Third question is 16 to the power 3 by 4. Okay. 16 we know 2 to the power 4 is 16. So instead of 16 we are going to write 2 to the power 4 to the power 3 by 4. In this the second law is applicable. The second law we have to multiply the exponents. 4 into 3 by 4. 4 got cancelled. We are getting, sorry, this is 2. Okay. This is 2. So 2 to the power 3 equals to 8 we are getting. Understood? The fourth is 125 to the power minus 1 by 3. It is given minus 1 by 3. So 125, 5 to the power 3 is 125 we know. So we can write it as 5 to the power 3 to the power minus 1 by 3. In this form also we know we have to multiply the exponents. So 3 is cancelled, getting 5 to the power minus 1, that is 1 by 5 is the answer. Understood? So we are going to into the last question. Last question is simplify. Simplify. The first one of simplify is, okay, first one is 2 to the power 2 by 3 into 2 to the power 1 by 5. Same thing again, 5 times I have already done it. See, it is written as a to the power m into a to the power n equals to a to the power m plus n. Instead of a, what we have? We have 2. Instead of n, what we have? We have 2 by 3. Instead of n, what we have? We have 1 by 5. Okay, we will do the addition here. This is 15. This is 5 times, so 2 into 5 is 10. This is 5 into 4, this is 3. So we are getting it as 2 to the power 13 by 15. This is the answer. Okay, simple a to the power m. Instead of m and n, you put those values that are given. 2 to the power 3, 2 by 3 plus 1 by 5. You do the addition, you are getting 13 by 15. So this is 2 to the power 13 by 15. The second one it is written 1 by 3 to the power 3 to the power 7. Okay, we know 1 by a to the power n can be written as a to the power minus n. So we can write it as 3 to the power minus 3 to the power 7. This one we know that in this second law is applicable. So this is minus 3 into 7. Minus 3 into 7. Minus 3 into 7 is 3 to the power minus 21. Okay, this can be written as 1 by 3 to the power 21 also. The answer. Okay, see this law is again I am writing here. 3 to the power minus 21, that is 1 by 3 to the power 21. This one. The third one is 11. 11 to the power 1 by 2 divided by 11 to the power 1 by 4. Okay, 11 to the power 1 by 2 divided by 11 to the power 1 by 4. Here it is a to the power m by a to the power n equals to a to the power m minus n. Same law. 11, m is 1 by 2, n is 1 by 4. When you solve it, it is by 4. This is 2 minus 1. So this is 11 to the power 1 by 4 is the answer. Understood? The fourth point 7 to the power 1 by 2 into 8 to the power 1 by 2. This is same, a to the power n into b to the power m equals to, we know we have to multiply the bases here. If the power is same, base is different and it is in multiplication, you have to multiply the bases. This is 7 into 8 to the power 1 by 2. That is, this is 56 to the power 1 by 2. This is the answer. Okay. So with this, we have completed the number systems chapter. There were a total of 5 sections. In the 5 sections, we have discussed everything: natural numbers, whole numbers, irrational numbers, rational numbers, real numbers, integers. Okay. Then we have seen the decimal expansion of real numbers. We have gone for the operations of real numbers, of addition, subtraction, how we are going to do. Then we have gone for the laws of exponents of real numbers also. So these were the 5 sections. I have covered it in 4 videos. Okay. So if you have doubt in any of those videos, you write it in the comment section. I will try to reply to those. Okay. I will reply. I will not try. I will reply to every comment. Every doubt I will reply. Okay. And try to clear those doubts of yours. Okay. And if you dislike something about the video, then also you write it in the comment section. Then also you write, so that I can improve it in the next video. If I am going too fast, if I am going too slow also. See, in the exercise time, I go a bit fast, but in the explaining time I go very slowly. If you have seen the videos, you can see that in the explaining portion, in the theory portion I go very slowly, but in the exercise part I go very fast. Why? To reduce the time of the video, one point. And the second point is so that when you do the exercise, you have to do it quickly also. Okay, so by looking you can you can slow down the video. This video you can slow down, okay, if you think that it is very fast, but when you do the exercise you have to do it very fast. So while learning you learn it slow, but while doing it you try to do it as fast as possible. Okay, and if you like also something about the video, then also you comment it, because this will give me a motivation to create more videos. Okay, so this is the end of the chapter number system. So the next video will be on the second chapter, that is polynomials. Okay, so till then, stay safe and take care. Thank you.